We have one other concept that we want to talk about here in this section, and that is the concept of finding area, because there are some related area formulas when it comes to dealing with areas of oblique triangles. So we're going to deal with two of them. One, if we know two sides and an included angle, then we can use this formula. Now, I'm going to explain this first formula right here. It says area is equal to 1/2 BC sine of A. So if we know an angle like A, and we know sides B and C, we can find the area of the triangle using this formula. Well, how's that come about? Well, remember that area of a triangle is always found by taking 1/2 of the base times the height. So we think about, well, what is the base and what is the height of our triangle? Well, in this case, it's actually very easy because the base is side C, at least the way I have it outlined right here. And the height, if you recall, the height was found by taking uh, area, A, sine of A, times A is H over B. So B times the sine of angle A, right? And so that's our height right there. And so it turns out that our formula, 1/2 C times B, or B times C, times the sine of angle A, will give us that area, just like we want it. Now, Heron's formula is particularly much more complex to prove, so I won't prove that right here, but this is a perfectly good formula for area right here. Heron's formula goes like this. The area, if we have all three sides of a triangle, is equal to the square root of the product, S, where S is what we call a semi-perimeter. We just take half of the perimeter, whatever it is, the distance along the outside of the triangle, times the difference between the semi-perimeter and A, times the difference of the semi-perimeter minus B, times the difference of the semi-perimeter minus C. Heron was a Greek mathematician from back in the day of Pythagoras, well, actually a bit after Pythagoras, but still a Greek mathematician. And so this is actually the formula named after that fellow. All right, let's talk about an example or two. Let's say that we have an area, we want to find the area of a triangle in which we know that the central angle B is 27 degrees, that side A is 15 inches, and side C is 24 inches. So let's use our formula to find the area. Just filling in with what we know, the area will be equal to 1/2 the base times the height, so that's going to be 24 times side A, which would be 15, times the sine of the angle in between them, so the sine of 27 degrees. So working ahead with our numbers right here, I'm going to get out my calculator so that I can do this along with you. You might want to check it yourself to see if I'm doing everything right. We're going to take 1/2 times 24 times 15 times 27, take the sine of that angle, and there it is. Area is equal to, my calculator, 81.72. We're going to round to this to the nearest hundredth. 81.72 square inches. Right? Doesn't get any more simple than that, and hopefully we don't have to do a whole lot of arithmetic by hand to figure that one out. So 81.72, and don't forget we are talking about area, so it has to be in terms of square inches. How would it work out with this second one? This is a little bit more of a complex looking thingy. We want to find the area of a triangle with sides A of 8 yards, B is 12 yards, and C is 16 yards. Maybe there's a surveying kind of problem right here. Well, what do we have to know? Well, of course, we want to know what our semi-perimeter is. Our semi-perimeter is going to be the sum. 8 plus 12 plus 16, all divided by 2. Well, 8 plus 12 is 20, plus 6 gives us 36 divided by 2, and so that is 18. So, according to Heron's formula right here, we're going to take the square root of the number that we get by taking the product of 18 times 18 minus side A, which is 8, times side the semi-perimeter 18 minus 12, which is side B, times 18, the semi-perimeter, minus 16, which is side C. So if we simplify that down just a little bit to make our work easier, we'll be taking this square root of 18 times 10 times 6 times 4. And you know, let's do a little bit of arithmetic here because we know how to do this kind of thing already. I'm going to say, well, 4. That's already a perfect square root. I can remove that. I also know that 18 is made of 9 and 2, and that 10 is made up of 2 times 5, and that 6 is made up of 2 times 3. So we've got times 4 right here. Let's see what we can remove right here. 9 is going to come out. 4 is going to come out. And then we have a pair of 2's right here. That's another 4. So what are we going to say right here? Well, this will be equal to 3, the square root of 9, times 2, the square root of 2 times 2, times 2, the square root of 4, times 2 times 5 times 3. That's square root of 30, which would be the same thing as saying 3 times 2 times 2, that's 12, times the square root of 30 square yards. But of course, we know that we don't normally talk that way, so we might actually go ahead and apply a calculator to see what number we're going to get. If I do that, of course, the square root of 30 times 12 will give us approximately 65.73 yards. So 67, oh, you have to look back at my calculator, 0.73 square yards. That's our answer. That's what we're looking for. What else could be easier? Good luck on the homework, and I'll see you in class.